Happy Thursday, guys. Today we're working on 3.06 common factors of polynomials. So your warm-up today is an amusement park charges $17 for each adult ticket and $6 for each child ticket. One day the park earned $3,640 in ticket sales. X represented the number of adult tickets sold, and Y represented the number of children tickets sold. If 200 or 400 tickets were sold on this day, which systems of equations could be used to find the number type? So remember, guys, this is setting up systems we finished off last quarter with, or last semester with. So go ahead here and take a pick of which one you think it is. So if we have $17 for each adult, remember each, that means I'm going to need to multiply. So that would be 17 times how much the adult tickets were used for. So the adult tickets were the X's. And we have $6 for each child ticket. So that would be plus 6Y. And remember, that's going to give us how much money is sold, or how much money we are going to make. So that's 3,640. And the last thing they say is 400 tickets were sold. Well, there's only adult tickets and children tickets. So to find the total, we would have to add those two together. So the correct answer would be looks like B. Okay, so today we are going to look at how can we find the greatest common factor of a polynomial. So we got some notes here. Remember quotient rule, right? This is going to be huge for finding the GCF. Right, quotient rule, remember, if we're dividing, we need to subtract those exponents. Okay, make sure you separate the variables and look for a match to divide. So remember, you're matching up your coefficients, your X's, your Y's. Okay, so you want to match what they're combining with. Step 2, divide like variables, subtract the exponents minus the top from the bottom. Remember when dividing the same variables and the same exponents, the answer is always number 1. Okay, so after you subtract the exponents, if it's positive, there is no fraction. If it's negative, remember you need to put the negative exponents in the denominator. Remember that negative switches it up. So this first one here we have is X's. So we want X, and remember 6 minus 4. Okay, so 6 minus 4 gives us X to the second. So X squared. Next one we have, and I'm going to go ahead and write this out. So we have got 8x to the 5th, y to the 2nd, over 4x to the 4th, y to the 2nd. So the first piece we want is to divide those coefficients. So 8 divided by 4. Okay, 8 divided by 4 is 2. And then we can subtract some exponents. So x5 minus 4 and y2 minus 2. So if we do that subtraction, we get 2x to the 1st and y to the 0 power. Now, anything to the 0 power, guys, is 1. So then if we take 1 times 2, that's just 2. Okay, or I always think about it as if I have 0 x's or 0 as an exponent, there's none left. Okay, so they're gone. And we only have 1x. Okay, so I'll write all that out. So we get x and then times 1. So if we combine those, that gives us 2x. Okay, or again, you can think about it as 0 means there's none left. Last but not least, we have 5x to the 3rd, y to the 7th over y squared. Okay, so we only have y's to combine. So the 5 and the x to the 3rd are getting left alone. There's nothing to do with them. But then we can subtract 7 minus 2, and 7 minus 2 is 5. Okay, so we get 5x to the 3rd and y to the 5th. Factoring is breaking up a polynomial in its most basic pieces. Hint, the factors multiply out to give us the original polynomial. GCF is the greatest common factor of all terms. This may include both numbers and variables. Variables for variables and the greatest common factor will contain the variable and the lowest exponent. So if it's most common, if I have 3 and 2, what they have in common is 2 x's. Okay, so it's always the lowest exponent. So GCF, guys, is essentially doing distribution backwards. Okay, so we've done a ton of distribution in this class. The greatest common factor is taking that distribution out. What can we factor out of both of them? So if we're doing distribution backwards, that means we're dividing. So both these terms can be divided by 5, so that's why the greatest common factor is 5. This one, the coefficients, the greatest thing we can divide by is 12, and then they both have an x in common. The lowest exponent would be the 1. We have to take the x out. Okay, and then here is also example of 3 terms. Same thing, just make sure you're looking at all 3 terms. So let's look at this first one. It says match the greatest common factor of each polynomial. Not all of them match up. So this first one, 3x squared and 6. So I always think, what can I divide 3 and 6 by? I can divide them both by 3. And then you want the smallest exponent. Okay, so x, just plain old x, would be the smallest. Okay, the next one, 24, 36, and 18. I think, what can I divide all 3 of those by? Well, I can divide them by 2 because they're all even. I can divide them by 3. And I can also divide them by 6 because I can divide them both by that. Okay, so the greatest common factor would be 6. And they don't all have x's. Okay, so the lowest would be a constant. Okay, so it has to be a constant. Last one, what can I divide 30, 35, 21, and 14 by? 7. So if we look at this one, and then we want the lowest exponents. This is a good practice for the exponents one. So here I see a plain old x, so that's a 1. This one has 4, this one has 3, so the smallest would be just plain old x. And then looking at the variables for the exponents for the y's, I see a 5, a 2, and a 3. So the lowest amount would be 2. So we want x, y squared. Okay, next one. But I don't know if this is going to copyright, so let me go ahead and write it down. So we get 4x to the 4th minus 10x squared plus 14x. Okay, so first got to think about, what can I divide 4, 10, and 14 by? Okay, well, they're all even, so I can divide them by 2. Okay, next thing would be 4, and it does not look like, well, I guess I could check 3 as well, and they cannot be divided by 3. 10 cannot be divided by 3. 10 cannot be divided by 4. The next one would be 5, and 5 doesn't work for 4. So the greatest common factor would be 2. And guys, if you want to do this, you can. So I've seen some students so that they know they're dividing because you're doing the opposite of distribution. And then the smallest exponent here, we got 4, 2, and then remember this is 1. So the smallest one would be plain old x. So factoring that out, we have 2x on the outside because we're doing the opposite of distribution. And this is where this comes in handy. 4 divided by 2 is 2, and then 4 minus the exponent of 1 is x to the third. Bring down that subtraction. 10 divided by 2 is 5. 2 minus 1 is 1, or just x. Last but not least, 14 divided by 2 is 7, and x divided by x is 0, okay? Or at 1 minus 1 is 0. Or you can think about it as those cancel each other out. So we get 2x to the third, negative 5x, and positive 7. And then you can check it if it's correct. So if I do the reverse, which is distributing, we get 2 times 2 is 4. X times 3, remember that's x to the fourth. 2 times negative 5 is negative 10. X times x is x squared. Ooh. And 7 times 2 is 14. Bring along that x. It does match up. Okay, number 6. We have 7x to the third minus 21x squared. Okay, so again, we want to think about what can I divide both 7 and 21 by? You divide them both by 7. Okay, and then the smallest exponent would be x squared. So it's the smallest. Okay, so then dividing them, we get 7x squared. Your greatest common factor goes out on the outside. And 7 divided by 7 is 1. X cubed, so 3 minus 2 is just x to the first. Now remember, guys, those 1s don't really do anything. So we can delete both of them, or erase both of them. Bring your subtraction down. 21 divided by 7 is 3. 2 minus 2 is 0. So there are no x's left. So we get 7x squared times x minus 3. Okay, number 7. We get 8a to the fifth minus 12a to the second. Okay, so what can I divide both 8 and 12 by? Both even, so I can do 2. Can't divide them both by 3, can't divide the 8 by 3. And you could also divide them both by 4. And I don't think there's anything higher. So we got 4 and 4. The smaller exponent is a squared. So our greatest common factor is 4a squared, goes out on the outside. 8 divided by 4 is 2. 5 minus 2 is 3. Bring down that subtraction. 12 divided by 4 is 3. 2 minus 2 is 0, so there's none left. So we get 4a squared, 2a to the third minus 3. And you can also check your answer by distributive property. I'm going to skip that just for time's sake, but you guys should check. All right, number 8, last one we're gonna do last one I'm gonna show you how to do, I should say. Okay, we got 15 r to the 4th s plus 25 rs squared. Okay, so both of these are not, I can't divide, sorry, 15, 25, can't divide them by 2, can't divide this one by 3, 4 doesn't work. Okay, the biggest one is 5, and typically those 5s are easy to see. And then we want our smallest exponents. So if I look here, 4 and 1, 1 is smaller. And 1 and 2 is smaller. So we got R and S is our greatest or our smallest. So what they have in common is what I should say. So 5RS is the GCF. 15 divided by 5 is 3. Another way to think about this, guys, if I have 4 and I take out 1, because think about like reverse that distribution, that gives me 3 left. So you could also think about it as that. And I have 1s and I take 1s out, there's none left. Okay, or you can think about it subtraction. So 25 divided by 5 is 5. 1 minus 1 is 0, so there's none left. 2 minus 1 is 1, so there's 1s left. And that's your answer. I would say for these really complex ones like this one, I would definitely distribute it back out because these ones look, oh, those are really tricky. All right, student practice is yours to do on your own. Make sure you give me comments so that I can, or questions in the chat if you have questions. So today's assignment is to do the worked out example in the try your own practice. Your graded assignment is 3.06. And remember, guys, Class Connect sessions are canceled tomorrow again for the outing. So make sure to check the email and announcements again for tomorrow. Have a fantastic day, guys.